Hello everybody. In this video, I'm going to be talking about one of the errors that we face a lot when dealing with some blocks in Aspen Plus, like the plug flow reactor. And actually, I got the question from one of the audiences asking about this error because he couldn't figure out what is the problem and how to deal with it. So I thought it's a good idea to like post a video to discuss this because it requires some knowledge about the way the software works and how it deals with the blocks in Aspen Plus. This is a plug flow reactor that we solved before, which was including a reaction with the Langmuir-Hinshelwood kinetics, and we saw that we were able to solve it, but the question that I got, that this person couldn't get this block solved, and he got an error which I'm gonna show you right now. So he did everything the same way I did, and he got this error which says that the calculation stopped because the maximum number of integration steps has been reached. It says maximum n steps equals whatever number is. It was 1,000 in his case, and in my case it's 1. Um, just to understand what is the cause of this error, we need to kind of revise quickly how the software solves the plug flow reactor. So the way it works is that and we mentioned that before for the PFR or for any distributed parameter system, that it breaks this PFR, whatever its length is, into parts, and for each part it does the solution, or it solves the equations simultaneously. These equations are the energy balance, the mass balance, and the equilibrium relations, with the summation of x and y equals 1, which are 4 equations. And to be able to solve them simultaneously, it does the iterative solution. So the software assumes some values and then does some changes to the values until the 4 equations are satisfied, and then it gets the output of the first part to be the input to the next part, and it repeats everything many times until the whole unit is solved and the results are produced. And this is how it works here. It works here in the plug flow reactors. It works the same in heat exchangers, in distillation columns, in liquid extraction columns. Whatever thing that works this way follows the same procedure. So one reason that can make the integration, and this is why the error says that integration, something has to do with the integration, so it cannot do the integration well, which is doing the calculations for parts till it finished the whole column. So one reason that could be causing this error is that the inputs that I give to the software are not suitable. Either they are far from the inputs, or they are not suitable for whatever I got, or because uh, and this reason is very common when you have a big flow sheet. So you have units before, and the outputs from these units is going to be the input to the plug flow reactor. So it has already done the solution for the outputs that were given before. And for some reason I changed the something in the previous units, and the input to the plug flow reactor now is changed, and it's using the outputs from the previous run as the initial values. So the initial values are far from the output that should be or that I should be getting with the new feed or with the new conditions. And this is why the inputs are not consistent. So one thing that we can do is to reset the simulation. And by resetting the simulation, I mean that I do not want the next execution of the selected item to start with the previous results. So I'm not gonna use the previous outputs as the initial values for the current run. So it deletes everything from the outputs, and it's kind of like a new start for the simulation. It helps a lot in many cases, and in such case, when I run the simulation, I could find this as the solution, but in my case, it's not the solution. So in this case, the output should be, or the cause should be something with the way it's doing the integration. So when the software does the integration, it has some limits that are kind of default values in the software, and these limits are mainly two parameters. The first is the number of integration steps. So as I mentioned, it's gonna do some integrations, many integrations until it's done. Being like a lot of integration or a small number of integration, it doesn't matter, but there should be a number of integrations. And one of the settings in the software that I can control is how many integration steps that it can do, which is the error that we see here. That the something has to do with the integration steps. Either I can let it do 1 integration, 10 integration, 1,000, million integration. I can give it the freedom to do as many integrations as it can. But of course, as I increase the number of integration steps more than what is acceptable, it will be like very like difficult in some cases, because the inputs will not be suitable to solve the reactor, for instance, and I'm letting it to do the integrations again and again and again and again, and it's gonna take many or very long time without being able to solve. So it's good to give it like a big number of integration steps, but not very much, because you have to get the thing solved quickly without spending a lot of time on like wasting your time on a problem that's not going to be solved. The other issue is that, or the other parameter is the tolerance, is which is the software, when it solves the equations, it assumes a value and then it recalculates it and compares the two values. If the difference in the two values is small, then it accepts this as a solution and it goes to the next step. The difference or the tolerance is the number that I like use to tell the software that when you have a difference smaller than this tolerance, then it's the solution is acceptable. So as I get the tolerance small, then I have to, or I'm telling the software that I need very high accuracy. So for instance, if I have the tolerance as 10 to the minus 5, then it means that if the two values, the assumed and the calculated values, have the first four decimal places are the same, but the fifth is different, then it's not acceptable. Then it has to be like the first five decimal places. And if I go to 10 to the minus 9, then I'm getting it even more difficult. So it could be solved, but the degree of accuracy is not letting the software accept it as a solution. So the place that we can control them is this convergence part here. And there is always the flash options, which has to do with like multi-phase. If I have more than one phase, then how the equilibrium calculations will be done, which is not the point we are interested in now. We're interested in the integration loops, which is the point of interest. It says first the integration convergence tolerance, which is the tolerance that we had just mentioned, and the default is 10 to the minus 5. And it tells here the initial step for integration variable. So it tells me if I have a reactor of 10 meters, of 5 meters, 1 meter, whatever, it's gonna break it into 100 parts. So it's 10 to the minus 2, which is 1 over 100. So it's breaking it into 1 over 100 of the total length. And this is going to be the step of the integration. I can make it smaller, I can make it larger. It doesn't matter. If you want to make it larger, make it. But again, it's going to, if you make it very small, it's going to make the calculation take longer time. And it might make the convergence very difficult. This is the maximum number of integration steps. The default value is 1000, but I made it 1 just to make sure that the error will show up. And when you make it 1000, then you're letting the software do 1000 integrations, which is gonna make the possibility of solving the block is very high. And as you saw, it just solved it in no time. So again, this is something that has to do with distributed parameter system. We can see it in RadFrac here. It's gonna be the convergence here, and in this part is gonna tell us something about the maximum number of iterations and the tolerance, and something about the algorithms. And there are very advanced things here that I'm not very familiar with, so I'm not gonna play with them. but just to let you know that this is available here as well. We can find it in heat exchangers when you open the heat exchanger here in the specifications. I think it was in the configuration, not in the specification. I'm not sure where was it. It's here in the convergence. You can find something about the convergence here. Again, the maximum iterations, the tolerance, again, the same. No, I'm sorry, I did a mistake. It's B8. Um, and you can find it in the setup here. Um, no, it's not in the options. I'm sorry. And here about the convergence, again, the number of iterations, some other things related to the temperatures, related to other things. So, anyways, I'm just like interested in highlighting the error and to like let you know why does this error happen and how to kind of tackle it. So I hope this helps, and I'll see you in the next video, inshallah. Goodbye.